Hello, what's up, guys? So, yes, this is Vignesh here. Hope you are able to hear me. Just let me do a quick audio check, or let me know in the chat box if you are not able to hear me. So, I will quickly tune in everything. But yeah, otherwise, so you might have seen the update which I had just shared. So, regarding the new series, structure. So this is the first episode of product development, which is going to be about use case and architecture. So oddly, we are starting off with product development, so that's because of the schedule. But I got a lot of feedback with the last episode which I had the other day, and while some of it was positive, the problem was that I was speaking so fast. So that's something which I try to correct. And in addition to that, the other feedback which was given was that there were too many topics which were being covered. One of my aim is to basically bring down the number of topics which we are covering this time, we can concentrate on something small but make it good. So with that, let's start off with today's session. So today's session is going to be about use cases and architecture, as I told you. So what I am going to do is I am going to show you how a use case, how an idea is taken, how a use case is being built, how the problem statement is structured. Then after that, how do you take the problem statement, how do you take the challenges, how do you take your expectations and build an architecture out of it. That's what we are going to see today, with examples, of course. So that's what we are going to do. So let's see. Before that, let me know if you are not able to hear me, so that I can quickly tune that. So if you are able to hear me, just leave a thumbs up. Okay, so moving on. Just give me a moment. Noticed, let me quickly get that update for you. So that's available in github.com/timecampus/neverstop, and we are going to cover 5 seasons in this. You can see the YouTube video where I have described what it is going to be all about. But yeah, so we will have use case and architecture today, then open world, then we will go like this. So I don't want to get into the introduction right now, but this is going to be a complete technical series, as let me get started. So first thing to any architecture is basically the use case. So what do you want to do? So why do you want to do it? So you have something in mind, you have an idea. So an idea is not necessarily a use case. So basically an idea is just a root of the use case. But use case is to be built upon the idea. So that's what is very important. So taking an idea, how do you convert that basically to a use case? How do you basically say, okay, this is what I want to do, this is what just let me know if you are able to see. I am not sure whether you are able to hear me. Are you able to hear me? First of all, let me do a quick mic check. So okay, so you are able to hear me then. Okay, good. So what we are going to talk about is the use case. So use case is a combination of multiple things: the idea, the problem statement, the expectations you have, and a lot of other things. So For instance, let's say I say that I want to make an app for doctor's appointment, for having doctor's appointment. So that is an idea. So that's not a use case. Use case is something like this. I want to make an app for doctor's appointment considering these factors 1, 2, 3, 4, 5, 6, 7. So basically I assume that okay, the doctor is going to be the one using the app. So I assume that the patient's information is going to be in the app. My requirement is the fact that whenever a patient comes in to the doctor, his basic entire history is reflected to the doctor. So yeah, this is one case scenario. And then once he comes and once the doctor sees the patient's history, he basically recommends all the medicines, and then finally he puts in all the recommendations he gives back to the app. So these are all the things, the entire workflow, basically workflow what you do with the entire app. So the consumer, who is the consumer, who is the person going to be servicing. So for instance, the doctor is going to service the patient, and the app is going to be used by the doctor in that case. So and you are going to use the app to basically record all the patient's history, and you are going to use the app in such a way that the records are stored in a confidential manner. And in addition to this, let's say the patient wants an archive of his entire health record, so he might want to download that. So that's also one of the requirements. So these are all your requirements which add up on the top of the idea, which becomes the use case. So that's what the use case is all about. So when you say this is the use case, that's when we can say okay, so this is what you want to do. So let's think about how we go about this. So that's when we at least get a direction that okay, given this use case, okay, this is how we want to do. So that's very important. Next thing is the problem. So the use case is not necessarily the problem. So given the use case, okay, the problem statement is the use case, yes. But given the use case, okay, what are the problems or challenges you think will face? Why hasn't anyone done this before? What are the typical challenges in the industry? So are there any regulatory constraints? Like, I mean, there are a lot of things, right? GDPR, and all the privacy regulations, especially associated to medical data. You might want to consider all of these factors into account, even when deciding the architecture, because that decides every aspect of what you are going to do with your product. So basically, starting from where you are placing the data, which region are you placing the data in? For instance, if you are using medical data of a Chinese citizen, it has to stay within Chinese borders. So that's also a constraint which you have to look into. So things like this become part of the problem or the challenge or the architecture as well. So considering, okay, you have defined the problem as well. So I am talking about theory right now. We will actually go into the practical sense how it is done. So considering you have taken all these factors into account, the next thing would be the expectations. What do you expect as the outcome? Finally, when you do all this, what do you expect as the outcome? What is your final expectation? So let's say your expectation is one. You make the job of the doctor very easy. So you just open the app, give the ID of the patient, and you get all the record of the patient. So that's one expectation. Another expectation is the patient has an idea of all the historical sickness he has, so that in case he wants to go from one doctor to another doctor, even the second doctor knows okay, what are the conditions which this patient has had. So this is one of the expectations you might have. So the patient might want to move from doctor to doctor and still maintain all the medical records. So these things become part of the expectation, which need not become part of the problem or the use case. So and then comes the architecture. So now, keeping all these constraints into account, okay, what you do is you don't go to the technology yet. Technology comes last. So you build out the architecture which is optimal for your use case and for your problem. So that's what you do. So what we are going to do is, okay, we have just spoken about this use case, right? So we have spoken about the doctor, the patient, and the history. So this is what our use case is, typically. This is what our use case is currently. So what we are going to do now is we are going to design an architecture right now and show how this workflow actually goes. But before that, let's dive into a few things. One thing would be there are a lot of architectural patterns. So let's say you want to model an architecture. So how do you explain an architecture? The way you explain an architecture is through diagrams, flow charts, or through representational diagrams, basically to say that okay, these are the blocks which I have in my product. Okay, this is why I need this, and this is my use case, and this is how it fits into my use case. There is no thing like one thing fits all. So I mean, one solution doesn't fit every problem, right? So that's what is important when you consider an architecture. By the way, in case you have any doubts, just interrupt me, I won't know otherwise. Okay, let me continue. So just a moment. Okay, so what I am going to do now is after the architecture comes the stack. So what I am going to do now is I am going to show you how it is modeled. So I am quickly going to show my screen. So let me open up my screen. Yes, I hope you are able to see my screen. Okay, what I am going to do is I am going to use my draw.io account to basically model this use case for you live, so that you can understand how this is done. I'm just signing in. Okay, I'm going to create a new diagram considering this problem statement. So let's do that. So let me name this as doctor patient. I am not creative right now, so I'm just giving this a name. So let me quickly select the folder. I use draw.io to model the diagram because one, it is free. Two, I can download it offline as an app as well. And three, I can import it, export it anywhere. So, and four, it has lot of tools available for me to model all the diagrams, flow charts and everything. So quickly getting onto it. So I hope you are able to see my screen. Okay. Now what we are going to do is we have multiple roles to play. For instance, doctor, we have, I'm sorry, I got a bit distracted right now because I kept getting a lot of calls, so sorry for that. So we have the doctor, we have the patient, and we have the app. So these are the roles. Let's talk about what we do with this. So first thing is, let's say, okay, what we want to do is we want to build an app which the doctor can access. So this is how it goes. So doctor wants to use the app. So now we want to make sure that the patient also can access the app. So this is not the architecture diagram. This is just to show you, how a use case can be described. A patient can also use the app. Now this means that if two people are using the same app, but the thing which you have to know is, even the doctor's data has to be stored in the app. The patient's data has to be stored in the app. So which means that there needs to be a mapping between the doctor and the patient. So like typically, let me quickly explain how this can be done. So let's say I'm just going to type in here, just considering this as a notepad. So let's say I have a patient mapped to a doctor. So what we are going to do is every time a patient doctor mapping happens, there are set of activities which can happen. There can be medicines which doctor gives, there can be the historical conditions which doctor might want to see. There might be reports or x-ray reports or whatever. So you might have lots of information. You might have personal information of the patient as well as the doctor. So you might have these kind of data inside the app. So basically the app might store all this information. So one thing to note is, so when the doctor and the patient are coming together, so which means that I need to store the data in one place, which is a database. So I have a database here. So the app is going to connect to my database. Now I can't talk to the database directly, right? So I need some sort of backend service which can basically talk to the database. So I have a server. So I have a server. My app is the client. So and then you have a database. And now this server is going to talk to the database. Now what happens is, this patient is going to have his own profile, this doctor is going to have his own profile. So but they have different roles. So this database can be partitioned by roles. So one role can be doctor, another role can be patient, and another role can be the hospital admin. So this is how you can probably model your database. So this can be the roles which you store in the database to access data differently. So now the thing is, if you see the app coming in, so the patient comes in, so he needs to have some identifying number, right? So that is a patient ID. So patient ID. So as soon as the person comes, the patient comes with the patient ID onto the app, and there is a doctor ID. So I say, okay, there is a doctor ID. Okay, but the patient comes to the doctor and meets him in a hospital. So there is a hospital ID. So doctor ID and a hospital ID. So so like this you keep building the diagram, and that's when you have components slowly. So keeping this aside, because if I start building this now, it will take a bit of time. So what I will do is I will quickly build this, just giving a commentary so that you can understand how it goes. So you have server. So the server need to have APIs so that my app can call the server. Now I need to have security at this API layer, basically, so that my data can be encrypted. I can have some JWT kind of security so that my app can be stateless, so that I can in case the load increases, so I can keep increasing the scaling up the server side, increase the number of databases, increase the microservices on the server side. So I can do all that with the stateless tokens. And then what I can do is I can basically build an app. So this is how it actually goes. So for the app I might want to choose, okay, I want to have a hybrid app. I want to build a hybrid app so that it works across all platforms. You code once and you use that across all platforms, Android, iOS, BlackBerry and whatnot. So I want a hybrid app. So for making a hybrid app you will need some sort of technology. So you can build the architecture like this, but finally what is more important is how do you make sure this architecture is scalable in the future. So if you make an architecture, for instance, so this architecture should be adaptable. Excuse me. Excuse me, I am getting a call. Sorry for that. I should be prepared for all this. Probably I should re-record this session as well. Oh God, this thing is getting tiring. So one thing to notice is okay, let me do one thing. Let me show you pre-built architecture. So this is a kind of a system. So you have a patient, you have a doctor, you have a clerk, you have a scheduler. You want to cancel appointment, make an appointment, request medication, pay bill. You might have a lot of activities you might want to do. So accordingly, depending on the use case, you basically model an entire thing. So excuse me. Okay, looks like there are some technical issues. I hear that people are not able to hear my audio, so I'm not sure whether you are able to listen to me. So if not, let me know, because we are already lagging behind. So there are a lot of technical problems today. Sorry. Okay, are you able to see my screen? Okay, perfect. Okay, what we will do is we'll quickly get on with this. I will probably re-record this as well. Sorry for the technical issues, but let me quickly explain how this thing goes. So you have a patient, you have a hybrid app, you have a doctor, you have a server, you have a database. So this is how these things are connected. There is a patient ID, there is a doctor ID, there is a hospital ID, and there is an API which you are calling. So I hope you are able to hear me. Okay, we are not able to hear now. Hello, am I audible? Okay, fine. So sorry for the trouble. So we have patient ID, doctor ID, hospital ID, API, and the database, the server, and everything connected together. So now what we are going to do is how do we decide what model to use? For instance, so when you are scaling up, so you don't want microservices always. So when you are starting an architecture, you have to always start small and scale it up gradually as and when you go. So for instance, this is just a single requirement, right? So if, let's say, assume the number of patients increases, so let's say the number of patients increases, you keep increasing the number of patients. What happens suddenly is this app is not able to handle the load which is coming to it, because there are a lot of patients. But let's say the number of doctors remain minimal. So what you can actually do is, rather than having to basically scale up the entire server side altogether, so you can actually have a buffer to say that, okay, if a person is serviced, that is when the server is used. Otherwise, I am going to use the offline application so that the load on my server is less. So when I just when a patient is just getting serviced by the doctor, that is the point when I use a server, not otherwise. I just download the data all offline, I cache it and I keep it. So when the person comes and meets the doctor, that's when I use the data. So you can make all such decisions when you do all this. So this is the kind of doctor-patient system, and when you do this, what happens is you have to basically decide a few things. For deciding your technical stack, for instance, what is the front end framework you want, what is the back end you want, and then what is the communication platform you want. So for instance, you can talk through API, you can talk through GraphQL, you can talk through some other means. So these are all the means you can talk through, but then you don't always have to use that. That's the fact. So for instance, you can start with REST API and then move on to GraphQL later. So we'll talk about all this soon. But then front end, back end, communication, then you might also have things like how do I manage my databases, what database to use. So then the next piece of the puzzle is, okay, now I have all this, okay, where do I host it? So now I have this as well. So now how do I manage the security? So now I have this as well. So now how do I manage the networking? So these are all the pieces which you need to put together when you make an architecture. So you need to say, okay, my patient, I need a hybrid mobile app, I need to make it as fast as possible, so I can use something like Ionic for a hybrid mobile app. If you need some kind of if you are looking for a performant experience, and if you are targeting limited platforms, if you have a lot of developers lying around, then you can go for native application. So let's say in my case, the decision is Ionic, since I am going to address a lot of platforms, Ionic and capacitor, let's say. Because I'm going to address a lot of platforms in a hybrid mobile app, and I have limited developers available with me. And in this case, the backend can be anything. For instance, let's assume you use the server only when you basically serve the patient. In such cases, you are going to use a lot of events. So for instance, you are going to look at the event when the patient has entered the doctor's cabin, the patient has left the doctor's cabin. So that is the time of service for the doctor. So, and you might want to also look at the database. There's not much compute involved here. So if there is a lot of compute, you might want to go for things like Go, you might want to go for things like Python. But in this case, simple Node.js would suffice, even you can use Java in this case. But the fact is, you want it to be light. So let me say, okay, I go for Node.js for this case. So but this can depend on your use case. For instance, if let's say I have a lot of compute requirement, I have a lot of procedural requirement in my server side, then I can go for something like Go, because Node.js has limited memory capacity which it can take. Okay, your screen is visible. Okay, thank you. In this case, Node.js is the backend which I am going for. So then communication. So communication, what I want to do is, basically I want to just make simple calls. Okay, I want to go and register to the doctor. I want to go and get service. So I can just go for REST API, because REST API stateless calls. Because what I am going to do is, there is not much requirement to view the data on the app side. It's all going to be a record system most of the cases, because and you always have a fixed set of data which you always want to show. You can go for GraphQL if you have a lot of bandwidth with you, and if you say that you want to go with something very scalable, okay, go for GraphQL, but to start with, it is too much. So next comes the database. So in such cases, databases, you need a relational database in this case, because there is going to be a lot of related data. For instance, a patient information, a doctor information, patient history. There is going to be related documents, there is going to be related hospitals, related cases, whatever it may be, but everything is going to be related to a patient and related to a doctor. So you will go for a relational databases, because that is what it shines in. So it shines in relations, and in this case, let's say you have lot of reads more than writes, or even a lot of writes. So you are not going to visit the doctor often, right? So you are going to visit the doctor only when you have an ailment. So in such cases, there are going to be limited writes but a lot of reads. So in such cases, you will go for something like MySQL. That should be good enough for you. So let's say you want to look at a host. So what hosting provider should you use? So I want a self-hosted solution. I want let's say since all my data is going to be private, it has to be hosted on premise, within the doctor. I can go for either a private cloud, so which either guarantees a protected network, or even if in most of the cases people are actually scared to go to the cloud. So what you can do is you can go for a hybrid architecture in this case, where you can keep all the PIA in your local data center, and you can which is personal identifiable information like a patient information, his medical history, all that in your local data center. And everything else, for instance, the time he comes, the time he goes, or whatever it may be, so the related conversations or whatever, so that can stay in the cloud. So you can have a hybrid architecture where you can have a VPN connecting to the on-premise system. So in such cases, what you can do is, keep the personally identifiable information privately on your premise, and keep whatever is not personally identifiable in the cloud. So thank you. So whatever is not personally identifiable in the cloud. And now next thing is security. Now the most important thing about this is security, because you are talking about a patient's history, patient's medical history. So which means that you need to keep it as secure as possible without any issue. So in such cases, what people do is they encrypt the entire databases. So if you go for a database like Postgres, there is something called as TDE, trusted data encryption, where they encrypt the entire database, and unless you have the key, you can't open it. In such cases, in case of hospitals, what you do is you divide the data as tenants, because you don't want one hospital's data to be mixed up with another hospital's data, or one patient's data going to another hospital. So, and you don't want hackers who hacked one hospital to also have access to a patient in another hospital. So you basically partition this information and have a partition tenant system with its own keys, so that with its own encryption mechanism, so that if you even get access to one hospital, you can't go into another hospital. You talk about WhatsApp end-to-end encryption, right? But how does that work? So you have a trusted key exchange between two individuals. In these cases, it is going to be a trusted key for a respective hospital or a respective doctor and a patient. So that's how it's going to be. So considering considering the encryption is going to be like that, so what we can do is we can have a tenant system. So we can have a sort of encryption, like for instance, for encrypting the database data, you can have, in case you are using Postgres, you can use, by the way, you can use Postgres as well here. MySQL or Postgres, both suit the use case. Let me know if you're not able to understand anything, so I can repeat. We are going over time today deliberately, because there were a lot of technical issues. So security, there are tenant which you have to talk about, there is encryption which you have to talk about, and then another thing is there is the network which you have to talk about. You don't want one network to be conflicting with another network. For instance, you have hospital's private network, you have the public network, so you need to make a sort of a peering between these two networks. So that's what we call as VPN peering. So we call VPN gateways. So when you have this sort of peering, what you can do is you can keep all the data privately, but still the data will be tunneled through and go to the cloud. It won't be accessible directly from the public internet. So rather it will be it will be accessible only through an internal network within which is binding to a private cloud and your on-premise servers. So coming to the network, you might want to use of course you will need subnets in this case. You will need VPCs in this case. You will need shared VPC, because you want to have a separate network for each and every hospital. So you don't want one network, you want this communication network to be separate between hospital and hospital. So you basically divide the network into pieces. So into different subnets. You can keep different subnets for different hospitals or different subnets for different regions, because in such cases, when you're talking about Chinese data, Chinese hospital data staying in mainland China, so in such cases what you have to do is you also need to think about geographical databases in such cases. So one thing to note about is in case of let's say YouTube. So YouTube maintains geographically distributed databases. So in case you are wondering what database YouTube uses, that's nothing but MySQL with Vitas. So Vitas is the backend. Vitas is the connector to MySQL, which enables YouTube to scale up databases to multiple places. We will be talking about Vitas in further sessions. But what you can do is you can combine MySQL with Vitas in this case, so that you can have patient's data geographically distributed, depending on where he is from. So if he is from, let's say, China, his data goes to Chinese database. If he is from somewhere else, it goes to some other region. And in such cases, you also need to maintain separate clusters. Let's say you are hosting all this in Kubernetes clusters, or you are hosting all this in VMs. You will need a separate VM for each and every region. You will need a separate VM or Kubernetes cluster for each and every region, so that you comply with all the regulations, all the GDPR regulations which you have. So this is how it goes, putting up the entire piece together. So and when you're talking about the doctor, so one doctor is not going to keep serving the same the same doctor is not going to be serving the patient altogether. So there are going to be multiple doctors who are going to look at the patient records. So in such cases, you might want to ask patient for permission before the doctor even accesses the data. So you might want to look at these kind of permission models when you are building the app. So this is how a use case and architecture modeling goes. So for instance, so let me quickly show you something interesting. So what I'm going to show you now is how Time Campus has how I have modeled the architecture for Time Campus. I'm not going to describe this because it's going to take a long time for you to understand, and it's already over time. But to give you an idea, this is how the architecture diagram for Time Campus looks like. I know you won't be able to see everything, but there are a lot of blocks and pieces. These are the clients. These are the various channels. These are or various platforms or connectors which we are accessing with. These are the various clusters, various regions. These are my subnets. These are my clusters, regions. So you basically build blocks like this. You build it doesn't come up all together at once. You have to scale up one by one. So you first have a normal client and a server. So that's how you start, right? So then, okay, you need something else. Okay, you add one more block on top. So that's how you make it incremental. So you don't build it all at once. Rather, you incrementally scale up. But when you are building the architecture, the most important thing which you have to remember is, it would look like a big robot because you are seeing it from a zoomed out perspective. But anyways, so when you are done with the product. In fact, I am not done with Time Campus yet, but still my architecture looks like this. Your architecture doesn't always have to be complex. My thing is complex because I always like to look at what challenges I may face in the future, and I like to build my architecture accordingly because if my technical stack is wrong, I can replace it with some other program, do something else, write my own software, do whatever I want. But if my architecture is itself wrong, it is very difficult to re-engineer everything, change everything. So that's how things go. So I'll end in 5 minutes. Before that, I want to quickly show you something. So for instance, this is an example banking system. I know you need not look at all this architecture. Okay, I hope you are able to see this. So this is a legacy banking system. This is talking to a telephone network, a mobile device, talking to a desktop. It's coming through a firewall to an internal network. Then people are accessing in the internet. So there are a lot of challenges involved when you are considering things like this. So when you are not building architecture from scratch, when you are taking in legacy systems and trying to basically scale it up. So in such cases, you have to look at a lot of other things like, okay, I have all these challenges. Now, how do I incrementally adopt this architecture? So how do I basically say that, okay, I take this piece out and I replace it with this piece. Okay, I take this piece out, replace it with this piece. Sometime it may work. Sometime you have to throw out the entire piece and rewrite everything, but not always the case. The cost of rewriting is always high. But if it is going to be worth it, okay, go ahead and do it. If you have the resources, if you have the time, if you know that it will lead a positive impact, go ahead and do it. But if you have a legacy system, the best thing to do is, okay, take away some pieces, okay, keep replacing it one by one till you get a state where things are decoupled, where you have Lego blocks. So architecture is like Lego blocks. You take each and every piece, you assemble it together, you get the entire building block, right? So that's how architecture is. So that's how you have to look at architecture per se. And what I will be doing is to make you understand a bit more about the architecture. Tomorrow I will be fixing AC in this room as well, so I am sweating a lot. From I guess in the I guess I have my factory every Tuesday at 9 p.m. So every Tuesday at 9 p.m. I'll be taking a use case and I'll be building a proper architecture. Today, haphazardly, I had taken some doctor-patient scenario, but we will take a proper scenario, build it from scratch, or you give me a scenario basically. You give me a scenario, what do you want me to build? I will build it in that 20 minutes time. Okay, so I'll end this session because it's overtime and I'll post all the remaining resources offline. But in outline, how you have to do is you have to keep your architecture simple, incrementally adoptable, scalable, and make sure your technical stack comes after your architecture, not before. You don't base your architecture on your technology. You base your technology based on your architecture. and also take into account the problem statement, the constraints given, and make sure that one more important thing which helps me a lot when designing the architecture, which I believe every person has to do, is the black box model. So you shut down everything. Just think about the input and the output. Okay, this is the input I give, this is the output I expect. Now find the black box. That's your architecture. Simple as that. So I give the input, okay, you expect the output, and I define the black box. So that's going to be my architecture. So that's how things are going to go. So when you have the black box model setup, you can have multiple black boxes. For instance, if I enter the let's say patient sign up information, I want the patient's record registered. In the black box, you might have things like validation of the patient details. You might have things like storing the information in the database. You might have things like connecting him to a respective hospital or a doctor, or a history or a record or something like that. All those are logic within the black box. So when you start thinking of your architecture as black boxes or black box model, it will become very simple for you to build architecture. So thank you for being there, and we will talk about the stack later in the next session. So you can ask me anything you want, and I'm ending the session right now. Thank you. So I am going to be available in the chat now, so let me know if you have any any questions, and I will reply back. Oops. Okay, I'm sorry for that. So initial 2 or 3 days it will be like this. So now I guess you are able to hear me. Okay, are you able to hear me now? Now? Now you must be able to hear. Okay. So the fact is that when you are going to design architecture, what I said was, when you are designing architecture, you need to look at things like how others have done it, how Uber has done it, how Facebook has done it, how YouTube has done it, how Microsoft has done it, Google has done it. So we need to look at all these cases, and then finally see how you can basically get some inspiration out of whatever they have done, and then adapt yourself. So you don't need to invent everything yourself, but ultimately what you can do is you can take inspirations from others. For instance, I didn't know about Vitas, so what I did was I had a look at how to make geographical database. I didn't get any idea. I wanted to see how other companies do it. I wanted to see how Facebook does it, how YouTube does it. So when I went across that is when I realized, okay, there is something called as Vitas, which Facebook, YouTube uses to scale up their entire database across multiple regions. So that's how it goes. You have to gradually take inspiration from others and then build your architecture. You don't have to build everything from scratch yourself. So that's how things go. I'll be fixing things, all of these technical issues in the next stream. I'm sorry for this. This is the I would say first proper stream, or maybe improper proper stream. I don't know, man. So anyways, so I hope this was better. I went a bit slower than my previous stream. I had changed the episode structure, so leave feedback on that. Whatever you have, let me know. So the thing is, since I had to re-engineer everything and then start the stream as well, so there was too much work to start with. So anyways, so thank you for joining. I don't want to keep you long. It's already 9:45. So good night, and I'll be in the chat. So let me know if you have any questions regarding the architecture. Otherwise, I'm just going to leave you all to it. And okay, let me quickly check Facebook as well. To all the Facebook audience, I'm sorry I have not been checking. So yeah, in case you have any questions as well, let me know. So I'll see you tomorrow. And tomorrow's session is going to be about the open world. So we will talk about the open source foundation. We will talk about oh, thank you, today was a lot better. Okay, that feels nice to hear, because that's how people grow, right? So good. I am appreciating myself. Anyways, so the Apache we will talk about the Apache Foundation, the Free Software Foundation, the open source, the Cloud Native Compute Foundation, the Linux Foundation. We will talk about this foundation, how they go about open source software development, the governance model they use, the licensing they use, how do they go about building the team to support all the community projects. But I feel like I'm directly in the third step without taking the first two steps. Vignesh, in the last session you told that Kubernetes was important, and I looked it up and I basically understood the basic and how it works and stuff. True, Kubernetes is important. The fact is, when you go with Kubernetes directly, I will guarantee you won't understand anything. One important thing is Kubernetes comes when you have already made the product and you want to host it somewhere. You have your workloads already, you want to host your workload somewhere in a distributable fashion. So Kubernetes is important. I am not changing my statement, but to start with Kubernetes is not at all good. So you won't get any idea when starting with Kubernetes. So can you suggest me things that I need to dig out before completely looking into Kubernetes? First thing is, okay, if you don't know coding, you learn to code. But before that, before doing anything, today's session is the most important, because unless you build a proper architecture, you don't have a product which you can even host in Kubernetes. So Kubernetes comes last. In fact, you can host in bare metal VMs before even going to Kubernetes. First, you need to get an idea of how the entire workflow looks like from the client to the server. How does the entire workflow happen? How do you basically put the entire piece together before even looking at how do you replace my server side with a microservice architecture, and why do I even need to do it? I mean, why do I need a microservice architecture? For what you may know, you may not need microservice architecture. You may not need Kubernetes. So don't go with Kubernetes blindly just because I said so. It is very important, but only when you look for microservices architecture. So otherwise, it doesn't make sense to look at Kubernetes at this point of time, at least. So next session would be tomorrow, actually. Initially it was planned to be Monday, Wednesday and Friday. But next session, for instance, the open world will be on Wednesday, for instance. So you can look at the GitHub repository where I have posted the schedule. For instance, okay, just give me a moment. So okay, even I have to check the session. So the next session is going to be, tomorrow is Thursday, right? So Thursday it's going to be live coding. So tomorrow I will take up a live coding session, but if you are looking into product development, it is going to be every Wednesday at 9 p.m. So have a look at this GitHub repository and you will probably know. The next Friday would be regarding the entrepreneur. So how do you go about building the product? As I told you, you have a look at the YouTube intro video to the series. You will get to know what the series is all about. You have a look at the schedule. You will get to know. So in case you don't have any other questions, let me know. So yeah, thank you for being here, and I will see you